Welcome to another episode. Today we're going to go over an angle of depression problem. For some of these problems, the students go crazy because they don't even know where to start. There's so many triangles happening in this problem. But I'm going to give you a strategy, which is color coding it and try to redraw some of the triangles so you separate the problems by pieces. Come on, let me show you what I'm talking about. Hugo is standing in the top of the St. Louis Gateway Arc, looking down on the Mississippi River. That's an actual place. It's actually pretty cool. You should check it out. The angle of depression to the closer bank is 45 degrees and the angle of depression to the farther bank is 18 degrees. Some people are going to shut down with that information. It's too much going on. I'm going to give you a hint though. We're going to work with that later. The important one in the beginning is it's 45 degrees. The arc is 630 feet tall. Estimate the width of the river at that point. Our goal is to find this right here, and we're gonna call that X. So I would draw something like that. Quick sketch. We're trying to find X, and for the people who get super confused in geometry, I think the reason why is that there's so much going on, there's so many information, it's hard to know where to start, and we're gonna give you a strategy today. We're gonna break it down into little pieces, and if we do that, it's not gonna be that confusing. So the two triangles that you see here is the red piece, and we also see a smaller triangle in the inside, which is green. Our goal is to find X. I cannot find X until I know this full length. X just represents this, and we don't know what this length is, so we're gonna call that and give it a name, just the next letter up, which is Y, and that is just from here to here. So just notice that this full length is Y and X together, or Y plus X. We're gonna focus first on that green triangle, and I'm gonna redraw it. Now I got the green, I don't gotta worry about anything else, but I do have to know at least one more angle in order to get Y. These two are parallel because these two are 90 degrees, and if these two are parallel, then you got a transversal right here that is really hard to see, but if you look closer, you can kind of see it. That transversal has a 45-degree measurement right here that was given to us. And like I said, that was the one we were going to use first, right? And if you got a transversal and interior angles, then hopefully you remember that opposite interior angles are congruent. So you know that this is going to be 45. If you did not see that in the beginning though, there is another way to find this angle right here, and that is the easier way. If this is 90 and they mark this as 45, then all you got to do is 90 minus 45 to get this other piece, which will make this 45. Let's just mark this angle first. We got opposite, OPP, and adjacent. You could do that, but if you remember your geometry, 45, 45, 90 is a special right triangle. If this is 630, then Y has to be 630 as well. That's if you knew that was a special right triangle. But if you didn't and you used tangent, here's the work. The tangent of 45 degrees, because we got an opposite and adjacent, equals Y over 630. And you could solve for Y, just multiply by 630 on both sides. Tangent of 45 degrees equals Y, and if you type that in the calculator, that is just 630 times 1, and we got the same answer, 630. So that's cool. Now we got Y, and we know Y. I'm going to erase Y now. We know that that is 630. Now we're going to focus on the red triangle. And let's fill out the information that we know about this red triangle. We know that this is 630. That was given to us in the beginning. We know that that's 90. That was also given. At the bottom of this triangle, we said that this was 630 and X. So we could just put the expression 630 plus X because we're just combining these two line segments. Now I need at least one angle to find X. There is a way to find this angle or this angle. I'm going to show you both. One, we said these were parallel, right? And now we also have another transversal right here. That is 18 degrees. That's the second angle that we were going to work off with. That's 18 degrees. So this is also 18 degrees. for the same reason. Alternating interior angles in a transversal are congruent. So we can mark this as 18 degrees. The other way that I figured out is this. This is 45, and to find this little dinky piece, we can just subtract 45 minus 18, and that equals 27. So this piece would be 27. Earlier, we said that this piece is 45, and look, these two pieces add up this entire angle right here. So 45 plus 27 is 72 degrees. That's the one I actually used. I used this one. Once again, we got the opposite and we got the adjacent. I don't know why they always use tangent. They seems to be the fan favorite. Now we can set up something like this. The tangent, because I got opposite over adjacent, of 72 degrees equals 630 plus x. That's my opposite over adjacent, 630. And now I can find the value of x by solving this. It's not too bad. Here's how you do it. Multiply by 630 on both sides. You end up getting 630 times the tangent of 72 degrees equals, well, these canceled off, 630 plus x. And the final step is just to subtract 630 to both sides. From here, all you gotta do is to find x, type in 630 times the tangent of 72 degrees minus 630 on your calculator, and we will get x, which is approximately 1308.94. I hope this tutorial helped, and the secret to it, at least what I do, is I like to color code things. I learn by colors. I don't know about you. And try to separate pieces. That way you're not so overwhelmed. It does take a little bit longer to redraw, but I promise you, the more practice you get, like with anything else, the better you get. If this helped, throw me a like, a subscribe. I'll try to run more geometry problems, but until then, I will see you on the next episode. Peace!